The maximum current I tried to draw out of this guy was 30 amps, and the manual says you can do 30 amps for 5 seconds. But there was clearly a thermal event on this little conductor here. You can see the brown below it and then the brown from this paper here that was on top of it. And the BMS did not shut down power for that. So I'm not sure if this BMS is correctly sized for the battery pack, or at least correctly sized for this nickel bus bar here. This is a lithium-ion battery designed to be a drop-in replacement for a 12-volt lead-acid battery. I was sent it to review for free. If you wanted to purchase it, it would cost you $32. They haven't paid me for my review, and my opinions remain my own. So in the packaging, you get a user's manual, which is quite glossy, has specifications, some dimensions, and a little bit of description. A battery charger, a lithium-ion battery charger, and the battery itself, wrapped pretty securely in a lot of foam. Alright, so here's the battery. It's definitely lighter than an equivalent lead-acid battery because it has lithium-ion cells inside. So the entire battery weighs 24.6 ounces. So that is 699 grams or 1.5 pounds. Dimensions wise, we have just a hair under 6 inches, just a hair over 2.5, and just a hair over 3.5. These look like 1/4 inch tabs. I'm going to have to get some calipers out to measure that. So the battery has a plug-in place to be able to charge it. So I don't know if you'll be able to charge this with the terminals or only discharge via the terminals. It has an on-off switch here. When you turn it on, it says, hey, I'm at 11.7 volts, and it has some green bars and some red bars. It looks like there's one bar that's not full here. All the rest are full. And it has 2 USB-A output sockets as well. So the charger has a barrel connector and a separate cable. This is for 110 US outlets. This is a universal input charger, so it'll do 100 to 240 volts, 50, 60 hertz. Its output is 12.6 volts DC, 3 amps. Okay, so the manual here says the maximum discharge current is 6 amps continuously. The peak discharge current is 30 amps for 5 seconds. And it says load power should be less than or equal to 100 watts. So, we probably should not be using this in a UPS that's trying to, power much more than, maybe a Wi-Fi router or a laptop. You want a 100 watt output UPS for this guy. Now your input charging, it says continuous charge current maximum 6 amps. So this provided charger here is definitely less than that. It's only 3 amps. I do not know if we can charge through the terminals, so we're going to have to investigate that. But first, I want to investigate this built-in USB power bank type feature here because there's absolutely nothing in the manual that talks about this. So let's just see what type of current we can get out of the USB-C ports here. Or sorry, the USB-A ports here. All right, so it's generating power 4.92 volts. I'm turning this guy on. I'm drawing 2 amps out of that. And the voltage is 5 volts, so it's able to provide 2 amps no problem. This little load will go up as high as 4 amps, so we're going to go up to the max and see what happens. So we're here at 3 amps and it's sagged to 3.7 volts. Actually, no, it's only at 2.35 amps. So it looks like 2, maybe 2.5. Let me go down to 2.5 and see. Yeah, so it's 4 volts at 2.3. So at 2 amps, 2.12 amps, the voltage is 5. So I'm going to say that's definitely rated for 2 amps. As soon as I start going higher than 2 amps, so here's 2.3 amps. Well, that's still okay. Let's try. All right, now it's flashing here. This guy is flashing, giving me sad flashes at 2.4 amps. And my lights here have gone down, so that looks like a voltage measurement at 11.3 volts. The lights are here. If I start drawing more, it starts flickering, and then it starts turning off. So I don't know if this guy here is separate from the actual connection to the battery. I kind of suspect this might be a direct connection to the battery, and this guy kind of is limited to 2 amps output here. And I'm almost certain that that's 2 amps for both plugs, so I suspect it's not 2 amps on each plug. I think it's 2 amps across the whole thing shared there. So you can use this to charge 10 watts, 2 amps at 5 volts. It does give you a battery voltage display here. Okay, and the battery terminals are disconnected from the battery until you flip this switch. So when you want to use it, you do have to have this switch in the on position. So the width of these terminals here are 1/4 inch. It's 0.25 inches on these terminals right here. Okay, I have attached this guy to a battery discharger. So I've set this to draw 6 amps until the battery gets down to 9.5 volts. According to this, the discharge cutoff voltage is at 10 volts. So at 10 volts, it should automatically cut off before this guy shuts itself down. Okay, it is drawing 6 amps of current, and the battery is at 11 volts. So not too much sag there on the battery while it's drawing 6 amps, which is the max rated draw there. Now that's continuous draw. It says it'll go up to 30 amps for 5 seconds. I'm not going to test that with this. I'm just going to let this run and draw it down until either this guy shuts off on its own at 10 volts or this guy shuts off at 9.5 volts. And we will have a running milliamp hour counter here that'll tell us how many milliamp hours we're taking out. Okay, this claims to be a 7 amp hour battery. We're discharging it at 6 amp hours, so it should last no more than an hour and say 10 minutes. Now, from the factory, it probably wasn't shipped fully charged. They say to store it in kind of the 30 to 60% charge area, so I suspect it wasn't fully charged at the factory before they shipped it out. So we're not really looking for the capacity of the battery right now. I'm just looking to see, will it turn off automatically at 10 volts, or will it allow this discharger to go below that to 9.5 volts? So we have the time-lapse camera. We're going to be watching the voltage. We'll see when it turns off. We will get a measure of the total milliamp hours that came out of the battery, but until I fully charge it, that's not really going to be useful. So after I discharge it, I'm going to fully charge it, and then we will do a discharge test to see the actual capacity. Okay, the battery discharger is done. The battery's currently at 10.3 volts, and it transferred 2.6 amp hours out. So the battery here says 10.2. It has 2 red bars and 1 green bar. Essentially, the battery has been discharged, so now it's fully discharged. I'm going to try charging this battery up with a standard 12-volt battery charger. All right, the battery charger detects 10 volts out of this guy. We're going to change it to AGM, and we're going to change it to turtle mode. And it's turned on, it is charging. Over here, this guy says 10.3, it just went up to 10.4, so the voltage inside is going up. This says, hey, I've detected a 12-volt battery, because the voltage is higher than a 6-volt battery. And what percentage am I done? It says it's 1% done. So we're going to let this guy charge it up. It went up to 2%. So it looks like it is charging it with just a standard 12-volt lead-acid battery charger. Alright, we're charging the battery with a standard 12-volt battery charger. It currently says I'm at 8% charged. Time-lapse camera is watching to see how long this will take. Or I'm not certain, but I think this guy may be done charging. The lead-acid battery charger thinks it's at 49%, but it'll charge for just a minute or two, and then it will turn off, as if the battery had been disconnected. And I think what's going on is the BMS inside of the battery, when it gets above the stop charging voltage, is disconnecting it from the terminals. And so at that point, the BMS disconnects, the battery charger stops charging, and then the BMS reconnects, and the battery charger says, oh, there's a battery there, I see voltage, I'm going to start charging again. So my smart battery charger here is attempting to charge it. It's gotten to what it thinks is 49%, and then that guy over there, every so often, seems to be disconnecting it. So it does look like it's putting more current in each time. It's not like it disconnects immediately. So I think if you let this go for a while, it would eventually fully charge the battery. It may potentially get it higher than it should be voltage-wise. So right now, the display on the battery is reading 12.6, and every single one of those green bars is, well, now it's 12.7, 12.8. Every single one of those, 12.9. It's going up a lot now. Let's see when it hits 13. It might auto cut off at some point here. So the voltage is definitely rising, and there, it just cut off. It went back to 12.2, and then it turned back on. So it does look like the BMS is shutting off the connection to the battery terminals when that current gets to be, when the voltage on the battery gets to be higher than it should be. So I'm going to say this guy is pretty much fully charged, as much as I can get it with the lead-acid battery charger. We're going to switch over to the battery charger that came with this battery, see how much more current goes in. So when I plugged in this battery charger, it's not drawing any real current because it's not hooked up to the battery yet. The green LED came on. I suspect that turns red while it's charging and hits green when it hits its high voltage mark. So we are going to plug that in to this guy here. That turns red, and if you follow this extension cord, I am monitoring how much current and so forth is being drawn out here. This reads 24 watts. So right now we are drawing 24 watts. So this battery charger is charging it at 24 watts, and that's the rate it's charging. We will see how much current goes in now to fully charge this battery. Alright, so when you turn this switch off, it turns off power to the terminals, but it does not disconnect this plug here for the battery charger. So it is possible to charge this guy up even with the terminals turned off. Okay, we have a green light on the charger. The battery is reporting 12.8 volts and all the little green bars are lit up. According to the kilowatt hour meter, the charger put 30 watt hours into the battery after I took it off of the 12 volt charger that was kind of starting and stopping and starting and stopping. Now, a 12 volt battery charger might eventually fill the battery up, but it was kind of charging it fast enough that the BMS was turning it off and then turning it back on, and then would charge it for a little bit longer, then would, turn it off, turn it on, charge for a little bit longer, and so forth. Okay, so this guy was fully charged. I got the green light. I have set my discharger to discharge it at 6 amps, go all the way down to 9.5 volts, or until this battery turns it off already. Alright, so we are starting, and it's ramped up to a 6 amp draw. It's keeping track of the milliamp hours here. So we've drawn 14 milliamp hours so far, and the battery voltage is sagged to 11.8 volts. Alright, I discharged this guy. Unfortunately, I lost the reading, but I saw it before I lost it. So it was above 7 amp hours. I think it was like 7.4 amp hours on the discharge on this guy. And this guy claims to be a 7 amp hour battery. So it is meeting its specifications there. It's also, another way to say that is 12 volts, 7 amps. It says 84 watt hour is the battery. So we are going to charge this guy back up, and it should take about 80 to 90 watt hours to charge it back up. Now, given that that's a 7+ amp hour battery, and that is a 3 amp charger, it's going to take us 2 hours and some change to get this guy fully charged up, probably closer to 3 hours. Okay, this guy's fully charged. We got a green light. It says 12.9 volts with all the green bars lit up. Going over to the power meter. So the kilowatt hour meter says we did 130 watt-hours to charge this guy up, which is significantly higher than the 80 watt-hours capacity it advertises. So probably there's a little bit of a parasitic draw on the charger overnight afterwards. It looks like the charger draws 0.4 watts continuously, just sitting there. Okay, it's 8:12 a.m. I have set this guy to discharge at 6 amps and go until it reaches 9.5 volts or until the battery turns the thing off. Okay, it is starting. It's ramped up to 6 amps, pulled 4 milliamp hours so far, and the battery voltage has sagged to 11.7 volts. It started out at about 12.6 volts. So this guy is going to discharge that battery. It'll probably take just a little more than an hour. I have the time-lapse camera watching it so I can tell exactly when it's done and what that milliamp hour counter says when it gets done. Alright, we are done. It says 7 amp hours, 7.4 amp hours. So basically 7.4 amp hours was transferred out. The voltage currently is 10.08. I saw it down at 9.5 before, so I believe this guy has not turned off with the BMS, but my discharger actually turned itself off. So I'm going to keep running this guy. I am going to change this lower voltage cutoff down to 8.5. Alright, so we're going down to 8.5 if the battery will let us do that. And it's drawing 6 amps. So over here on the battery, it says 9.4 volts. The one red light is blinking. It's basically at its low voltage warning. But this guy is still drawing 6 amps. So I'm not sure if the BMS is going to do a low voltage cutoff at some point or not. We'll find out. Okay, it has shut itself down again. I think the BMS turned it off there. I think the BMS turned off power and then turned the power back on, and this guy is not going to draw anymore because it detected that the power went out. So it does appear to have a low voltage cutoff, about 9.5 volts, 9.3 volts, something like that. And this guy transferred 7.4 amp hours out of this battery. So it's a 7 amp hour rated battery. It got 7.4 out, so it's definitely meeting its specifications there. I'm going to charge it back up so we're not leaving it at a low voltage condition. Alright, it's 9:30 a.m. and I am going to be charging this guy up with the time-lapse camera. We'll see how many hours it takes to charge up with that 3 amp charger. I've also reset the watt-hour meter, and we'll figure out how many watts it takes to charge it back up. Alright, this battery that claims to be 84 watt-hours is now fully charged. We got the green light, and the charger took a total of 100 watt-hours. So that seems pretty reasonable that it put at least 80 watt-hours into the battery, even if, 20 watt-hours was for charger inefficiency losses. According to the manual, peak discharge is 30 amps for 5 seconds. So I've set my discharger to 30 amps. We're going to go until the voltage hits 9.5, or until this guy cuts us off, or until I get scared and decide to turn it off myself. Okay, so it is ramping up the current. And this battery appears, the battery turned itself off at 25. So I saw it get to 25 amps and then the battery shut itself down. So it is not really reaching the 30 amp max there. I saw it hit 25 amps and then the battery shut it down. I'm going to redo this test with this guy set at 25 amps. All right, we're going to try drawing 25 amps. Okay, it's ramping the amps up. The voltage is sagging. This display's going down. Okay, it is drawing 25. Oh, and it shut off. So the BMS is shutting it off when it gets above the amp draw. It says it could do 30 amps for 5 seconds. I didn't see that happen. Let's find the place where it is consistently putting out amps. All right, we're going to try 20 amps. Okay, ramping up to 20 amps. There, it's drawing 20 amps. We're sagging down here, 10.7 volts, 10.6 volts, 10.16 volts. Fan turned on to dissipate some of that heat. Okay, it looks like this guy is able to provide 20 amps at least for a handful of seconds. Now the battery voltage is sagging really low here. It's 9 point, and it shut down because of battery voltage sag. Okay, so it can provide 20 amps for 10 or 15 seconds. I think my discharger shut down there due to battery sag, and realistically I think that's the right choice. So 20 amps, maybe for brief bursts of time, but let's try 15, see if we can go longer. All right, ramping up to 15 amps. So we're getting some voltage sag. It's down to 10.8 volts. Now over here we still have 3 green bars, so it seems like it maybe can support this for a while. 10.7 volts. Now keep in mind, 6 amps is the maximum sustained discharge that this guy is rated for, so I'm exceeding its ratings by a little more than 2x here. Our voltage was sagging down to 10.6 volts there. Alright, looks like it's able to maintain 15 amps for a decent amount of time. I'm not detecting any undue heat. Might take some time to build up and go out through the plastic case though. Okay, I'm going to say that you can pull 15 amps for, a decent amount of time here, say a minute or so. Alright, so this guy weighs 1.5 pounds. Or exactly 700 grams. It feels not super dense, and there's definitely a weight distribution where there's more weight on this side than that side. I expect there's battery cells over here, and then this little meter and USB charging circuitry over there with a switch here. So this is a drop-in replacement for a 12 volt 7 amp hour lead acid battery. It claims 84 watt hours, 7 amp hours, and it does meet those claims. It doesn't exceed them by a whole bunch, but it definitely meets those claims. So the advantage of lithium ion is that you have more cycle life, longer lifespan, a much lighter weight. They claim to be using lithium iron phosphate here, which is a relatively safe chemistry. You don't have to worry about burning. I have not cracked this open to look inside to see exactly what type of cells are in there. So you'll just have to see if you trust them on that or not. So output capacity is going to be just as good as a lead-acid battery of a similar size. When I tried drawing 30 amps out of it, the voltage sagged so much my discharger turned off. So, you know, your voltage will sag quite a bit. Of course, you try to draw 30 amps out of a lead-acid battery, the same thing happens. I could get 20 amps drawn out of here for a minute or so without things shutting down. And you could draw 6 amps out of it continuously. So I think if you have a scooter that takes 2 of these batteries, if you replace the lead-acid batteries with these guys, you're probably going to see a little bit faster acceleration. The battery life of distance traveled will be about the same, but the lifespan for number of times you can recharge it will be better. The performance of your scooter might be a little better just because the scooter will weigh less. It'll be easier to carry around, take less power moving the scooter as opposed to moving you. So it appears to do what it claims to do and to meet its specifications. I'm a little hesitant to recommend this for unattended applications like a UPS system, just because with lithium-ion batteries there is always a small risk that it could burst into flames, more so than lead-acid batteries. I also don't know how much of a parasitic power loss this little meter and the USB circuitry here provides. So that's probably going to be more parasitic loss than you have on a lead-acid battery sitting, just sitting there. Now, charging it, it does include its own charger. You can plug in and charge it up. It also was charging off of my standard lead-acid 12-volt charger, but with that, it would charge up, the voltage would get a little too high, the BMS would shut it off or disconnect it, the BMS would then reconnect it, it would charge a little bit more and so forth. So it might take longer to charge this guy up on a lead-acid battery charger because of the shutdown and startup cycle. I don't know the charging speed on a lead-acid battery charger versus the plug-in charger, but it did look like it was charging off of a lead-acid battery charger. So it looks like if you have an application that charges these guys and keeps them topped up, the BMS will automatically cut that off if the voltage gets too high. So after my discharge test where I tried to pull 30 amps out of this guy and succeeded in pulling about 20 amps out, there was a distinct smell of cooking marshmallows. So I cracked open the case and I found a little black mark on this protective paper here. So apparently, yeah, there's more black marks in there. So apparently something got very hot right in there. I think this trace here got quite hot because we were pulling a lot of current through it. And so that turned this paper brown. And I don't know if this is special paper that's been treated not to burn, but it did not burn, it just browned. There's also some of that protective paper down here, and it also browned a bit. Now you can see inside there is a battery management system. So right down in there, there's a BMS. It looks to be, pretty decent size, probably 20, 30 amps. So it does have the BMS down there protecting the cells. You can see here's the set of cells. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 cells. They look to be in 3 series, 4 parallel arrangement. They appear to be just standard 18650 cells. And I don't know if standard 18650 cells come in lithium-ion phosphate or not. They certainly could, but you can see that they're all kind of on this side of the plastic case, and then on the top here we have the charging jack here, which goes right to the BMS, and we have the battery from the cells coming out here, and there's the switch that can turn that power on to these 2 terminals and the USB and battery meter there. So, it's kind of what you'd expect to see inside. I'm happy to see there is a BMS in there. It does look like drawing 30 amps out of this is way too much for it due to the overheating and browning of the paper that happened there. So I definitely say do limit your draw to the 6 amps maximum recommended. I'm going to break apart this glue and see if I can pull the battery pack out so we can read what's on those cells. So now that this is out of the case, you can see how that nickel metal right there is quite discolored, and it definitely got heated up, and you can see the kind of the brown marks on the paper below it. It didn't melt, it just got very hot at some point. So the battery management system looks like this. It has a serial number on the bottom, YHZX4333 3S 12 amp. There's exactly one hit on line for that serial number. I can't read the writing, but I see a 5 or 10 amp here. Alright, the maximum current I tried to draw out of this guy was 30 amps, and the manual says you can do 30 amps for 5 seconds. But there was clearly a thermal event on this little conductor here. You can see the brown below it, and then the brown from this paper here that was on top of it. And the BMS did not shut down power for that. So I'm not sure if this BMS is correctly sized for the battery pack, or at least correctly sized for this nickel bus bar here. So I would not recommend using this battery in an application where you might inadvertently draw high currents like a scooter or e-bike. I think if you can limit your draw to 100 watts per battery, that might be okay. So if you had a scooter with a 250 watt motor and 2 batteries, you'd probably be okay. But it looks like it might be better for 6 amp draw as opposed to 20 or 25 or 30 amp draw. If you don't want the parasitic load of the USB port and battery monitor, it'd be very simple to unsolder, or clip either or both of these 2 wires and take that out of the circuit entirely. The cells have only this logo on them, and so I don't know the exact battery chemistry